Hello and welcome to part 3 of creating a simple 3D move and dodge game using the Godot game engine. My name is Colin, and in this video series, in about 12 videos, we're going to be creating this simple 3D move and dodge game. You play by being a ball that you roll around a 3D maze. In the game you collect coins, you avoid rolling enemies, and if you collect all the coins you win and go to the you win screen, and if you hit an enemy you go to the game over screen, and then you can go back to the menu and try again. So in this video we're going to go over a few things. Specifically, we're going to look at how to get a model and its material from Blender 2.8 into Godot. So the export process and the settings that you'll need to change in order to make that work. We're also going to add simple materials to mesh objects in Godot that we made in Godot, and we just want to add a material to it, so materials in Godot. We're also going to add rotation to our ball, so when you move the character, the ball in the game, it actually rotates in the right directions. So we'll go over that. And last but not least, I promised this in the last video, I think, but I didn't include it. We're going to learn how to change actions. That means that we can not only move our character using the arrow keys on our keyboard, but we'll be able to move them with whatever keys we want, like the W, A, S, and D keys, the directional letter keys on the keyboard. But this is part 3 in this mini-series. If you've not seen part 1 and part 2, if you have not seen those, I'll put a link to my Godot 3 tutorial series on the screen right now, so you can go ahead and check that out if you haven't seen the first 2 parts. Also, of course, if you like this video, if you learned something, go ahead and click on that like button below this video on YouTube. It really helps me out. And if you want to see more videos like this one in Godot or Blender or in tech, click on that subscribe button as well, and click the bell icon to be notified whenever I upload a new tutorial. So let's go ahead and jump in. The first thing I'm going to do is show you the model that I'm actually giving you a link to download the blend file for Blender 2.8 in the description area below. The file is right here. It's called playerball.blend. That's a Blender 2.8 file. If you're in the future, July 2019 or later, if you go to blender.org, you can get, most likely by that time, July 2019, Blender 2.8 will be a stable release. And so that will be the new version of Blender. Up until now though, it's just in beta. So on my desktop here I have the portable beta version of Blender 2.8. So I'm going to go ahead and open it up. And if you have not seen 2.8, this is what it looks like. A little bit different than 2.7 in the past. So let's go ahead and check this out. I'm going to go to File and Open. Go to my desktop. I've got a file here called playerball.blend that you've seen already. If I open it up, this is what we get. This is my character. It's a simple ball. It's really just a sphere. We're going easy here, and the sphere in the right hand side properties editor under the little ball material tab, it has one simple material that I have named Luxo material, like the Luxo ball from the Pixar shorts and movies, and that one simple material just has 3 nodes. If you're familiar with nodes in Blender, they're a way of building a material up and making very complex materials, although this is really not much more than the basic material that you would add to any object in Blender 2.8, except besides just having a principled BSDF material, it has an image texture plugged into, instead of using a simple base color, it has a picture instead, and that's this picture over here. If I go to the 3D editor window and press tab with the ball selected, I can go into edit mode and you can see all the edges and vertices and faces, and you can also see, because I have it all selected, if I press Alt A, it'll deselect, or A to select in edit mode, you can see all of the vertices up here. You'll also notice that I made a seam around the equator essentially of this model, and that's because, or you can see that if I press Alt A, it's red, so that's where it gets split up. This is a UV map or UV layout up here, and so it works. And this image file is actually packed into this Blender file, so if you get the Blender file, you have access to the image file as well. So this is our model. The one thing I'll say here is that I do not have any cameras or lamps or anything else in this file. If you do, that might make things a little bit more complicated, but we'll talk about that in a moment. The other thing that you need to do if you're taking a model from Blender to Godot is make sure you name your materials very uniquely. If you bring in 2 different objects from Blender into Godot and they both have the default lazy material.001 material name, then you're going to run into problems because Godot is going to recognize that they have the same material from two different files perhaps, and it's going to give both your models the same material. I wouldn't also go too complex on your node setup. This is a very basic node setup. In Blender you can make lots of crazy materials by combining tons of different nodes. I don't know how well Godot would handle that. So that being said, if we go up to File and Export with the ball selected, there are many export options, and the most popular kind of file that you need to export in many cases is called a collada file. A collada file is a .dae file, and that is the most mature out of any of these file types to get to Godot, but most people recommend that you use a different exporter. It's an add-on for Blender called the Better Collada Exporter, but we're not going to be using that. Why? Because I don't want to go through the messy process of installing an add-on, especially because I'm not using an installed version of Blender. It's the beta in a folder on my desktop. So instead, we're going to use a newer kind of file type under File Export called GLTF 2. And this is a new kind of file that Godot will read, and it's new to Blender 2.8. So let's go ahead and click on that option. And you can see this is a save editor here. So I'm going to go on my desktop and I'm going to name this player ball. But over on the bottom left there are some settings, and if I make this a bit wider you can see them a bit better. There are tabs for different pages of settings, and you really have to be careful here not to change the wrong ones. Everything is almost good by default, except that we want to change the format from GLB to GLTF embedded. I found that that one works really well. I'm not too sure about the others, but this one does definitely work. So that's a very important setting to change. The other one that you might want to select is selected objects if you have other things in your scene and you just want to export one object. Okay, that could also be if you have cameras and lamps in your scene and you don't want to select those two. Okay, so on my desktop I'm saving a GLTF file and it's called player ball, and I'll click export GLTF. And we're done in Blender. So I'm going to minimize that and open up Godot on my desktop. And let's go ahead and open up our game project. And of course, because now we have a character scene in our assets folder called steve.tscn, we're going to look at that. But first, let's go ahead and look at level.tscn. This is our main level in our game. So we have our Steve instance right there. If I select Steve over here in the scene dock, we can select him. What I need to do here is actually go into Steve's scene and change the mesh. Before I do any of that though, I actually need to bring that GLTF file into my project folder. It's not. And I've got an assets folder for all the objects that I create as separate scenes in my game. But I'm going to make a new folder now. So I'm going to right click on this word res. I'm going to say new folder. And I'm going to make a new folder called imports. Okay, you can name this whatever you want, but I think that makes sense. And I'm going to press OK. So now I've got an imports folder. I'm going to minimize Godot. And just inside Windows, I'm going to go to my project folder. And now you can see I have a folder called imports, not .import, but imports. And I'm going to go into it. And this is my playerball.gltf that I just exported from Blender. I'm just going to drag that in there. And I'll close this now and go back into Godot. And did you see it? There was actually really quickly a little scroll bar dialog box, or a progress bar, pardon me, dialog box, and that was it quickly importing the model file. If I go to my file system dock at the bottom left and I go into imports, you can see there's a playerball.gltf and a luxo material.material. This is a material resource, and that's what it was doing when it was importing. It was taking the embedded material in the GLTF file and making it into a separate Godot material for us. Now, if I double click on playerball.gltf, it will ask me, scene playerball.gltf was automatically imported, so it can't be modified. To make changes to it, a new inherited scene can be created. What is it saying here? Well, a GLTF file, when Godot imports it, it considers it its own scene, which is good usually, because you want to make a character like this or an object its own scene usually in Godot. We learned that in the last video, but it's directing us to select, and this is the default new inherited, and I would not recommend that. I would just go ahead and say open anyways. And the reason for that is when you use open anyways, it'll open up this GLTF file as a scene, like a tab in the top, and it'll make it look like a scene. It'll have a default spatial node and a mesh node for our mesh, and we can see it in Godot here. But if you were to, I'm going to go backward a little bit, if you were to double click on playerball.gltf and select new inherited, the things that are inside the scene would all be grayed out, and that causes more headaches than it's worth. So I'm going to close that. By the way, you could actually just drag in the model, but again, I wouldn't recommend that either. There are better ways of doing it, and that this is a messy way. So let's go ahead and press Control Z. I'm going to double click on playerball.gltf, click on Open Anyway, and right away I'm going to save as this scene. So scene, save scene as, to make a new copy of it as a kind of a file, a TSCN file that we can actually edit in Godot. You can't actually edit a GLTF file. So I'm going to go to save scene as, and I'm going to go out of my imports folder. So I'll click the up arrow and go into my assets folder, and I'm going to name this playerball.tscn. Now, we're actually not going to use a scene file. I'll show you why in a moment, but what we're doing right now is what you would normally do in order to get an object from Blender into Godot and make it its own scene, so you could then instance that object in any level or scene in your game that you want. We're in a little bit of a different situation though. We already have a Steve scene and a Steve object that's instanced into our main level already. So all I want to do actually is get the raw mesh and take it from this new playerball.scene and bring it into our Steve scene. So we're not going to actually use this very much, but I'm going to save it in my assets folder anyways. Now, one thing that you might have done before clicking on playerball.gltf is you might have selected it down here and gone up to import and changed a few settings, especially the root node type, which by default is spatial. If you go and look at this player ball scene, a root node is a spatial. But if you're familiar with Godot enough to know that a character object is going to be a kinematic body, then you can change the import behavior of this GLTF file. If you select it again, go to import, you can change it to whatever node type you want. In this case, I'm going to click there and search for kinematic body 3D, not the 2D one, and click on create, and then I can say re-import, and that's something I might have done before I saved playerball.tscn. Instead though, I'm going to go to scene in playerball and right click on this spatial node, and I'm going to say change type, and that's just as easy to do. And I'm going to select kinematic body by just searching for it. There we go. So now our root of this new player scene is kinematic body. Now it also needs, besides a mesh, it needs, what's the little error? It needs a collision shape or a collision polygon. So I'm going to click on the root and I'm going to press the plus. We're going to type in to the search bar collision shape, and we're going to use the 3D one, not the 2D one, of course. So click on the 3D one, and the shape needs to know its shape. So I'm going to select it and go over to my inspector and select a box shape, just like we did it in the last video. But again, I'm actually not going to use this scene. Instead, we're going to steal the mesh from this mesh node right up here. If I select the mesh node, you can see this mesh is over here. I'm going to save this scene first though. Now, what I can do is look at this resource of this mesh node, and I can save this resource into my project folder and then steal it or reuse it in my original character scene. So I'm going to click on this little arrow and I'm going to say save. I'm going to save this resource. So I'm going to go to my assets folder. I think that's okay. And this is going to be called playerball.tres. This is a resource file in Godot 3. So I'll click save. Okay, so following me here, I'm going to close this scene now. We're not going to use it, although you could use this if you hadn't already made a character. You could instance this in your level. I could go to link or create new instance, and I could make an instance of playerball.gltf, or pardon me, the playerball.tscn. We don't want to use that GLTF anymore. And I could press open and I could have the ball. But instead, we're going to update our one that has the code on it. So I'm going to go to Steve, which has the script on it from before. And I'm going to go back to my 3D scene. And I'm going to go into Steve's scene. And here Steve is a kinematic body. He has a collision shape, which is a box, and he has a mesh, which in the last video I just made from a default primitive sphere up here with the mesh selected. Before it had nothing. I'll go to clear. I just went to a new sphere mesh. Instead, I'm going to go to load. And now I can select from my assets folder that TRES file of my Luxo ball player mesh. So I'm going to click open with it selected, and there we go. There is the ball. And as you can see, if I go to my front orthographic view, you can see it's the exact same size as it was because that's how I planned it from Blender. And if it wasn't, I could change the scale, the geometry, I think, or transform, pardon me. I could change the scale over here, but it's good. So I can save this, Control S. I can go back to my level. There's my ball. If I press the play scene button, I can play my game, and it works just like before. I can move my character around. I can even push the box that's a rigid body off the edge of my platform. So I'm good. So that's bringing a mesh using a GLTF file from Blender 2.8 into Godot. Let's quickly talk about materials. I'm going to select my floor. We're going to add a color to my floor. It's just got no material on it right now. My floor again has three parts. It's a static body. It has a collision shape, a big rectangle force field, and a mesh instance. And the mesh instance is just a stretched, simple cube or box mesh. But if I select that mesh instance in my main level scene, I can go over and look at it in the inspector. And if I actually just click on its little thumbnail, it'll expand information about it, including a material slot. And it's empty right now. It has no material. So what I can do is I can click on the little arrow next to it, and I can say new shader. No, we're not going to use shaders. Shaders are more complex materials that you can actually code and use node setups, but we're just going to use a spatial material. A spatial material is much more what you're expecting if you just want to change the color of a object's material. So a new spatial material, and there's a preview of it. If I click on its little icon, we're going to kind of go to the next page in this window. We have little back and forward buttons like a web browser, but this is the page that shows us all the options for the material, and there are a lot here. If you're looking for color, the property you're looking for, or the heading, is called Albedo. Albedo basically means the color of reflected light coming off of an object. So I'm going to expand that albedo section out. I'm going to select the color just by clicking on the white box. We're going to make the color of the ground, I don't know, green. Okay, and then I can just click somewhere to get rid of that color picker. And as you can see, it's green. It looks kind of blue, kind of like everything else, because our sky is blue. We'll talk about how to fix that in an upcoming video, but this is a simple way of changing the color of an object, albedo, and we can press the back button to go back and see our mesh properties, and I can select any other node and we can see its properties over here. Okay, so that's materials on mesh objects that you create inside of Godot. If you're wondering, if you select Steve and go to his scene, and we go to his mesh instance, the mesh that we brought in from Blender, this mesh actually has the material in a different slot. If I look at if I expand it out, it doesn't necessarily have the same material section. There is a material section on the outside of the mesh, kind of. I'm not really sure why there's two spots, one for surface and one for material. The material appears to be empty, but when you export to GLTF from Blender, it gives it a material, or surface with a material on it. But I believe you can have multiple surfaces and multiple materials if you want from Blender. So here we have under surface 1 a slot for the material, and I could even save it as a material resource and put it on other objects, but that's where things are for this. Okay, so I'm going to close Steve, the scene, and we're back in our main level. Next up, let's program our ball to roll, because if I play my scene, of course, the ball just skids around. Now, if we actually look at Steve, if I go into his scene, you can see that he's a box, really. He's a box with an internal mesh for looks only sphere. And if I select his collision shape, we can see the box. It's going to be sliding along the ground. So we're actually not going to make Steve himself roll, because that would be rolling a box on a floor and that wouldn't work very well. Instead, we're just going to fake it, and we're going to roll the internal, or rotate the internal mesh inside of the ball as if the ball itself was rolling. So let's go ahead and go back to our level, and I can close Steve because we're not actually going to work inside of Steve. I'm going to go to Steve and I'm going to look at his script. This is the code that we finished in the last video, so I'm going to go ahead and let me clear this output panel so I can make that, can I make it shorter? No, I guess I can't. I can make this full screen now. Good. This is the code from the last video in which we used if statements to detect if we were pressing arrow keys, which are really called actions on the keyboard, and if we pressed the keys that are associated with UI right, UI left, UI up, UI down, these are the names of actions, then we move our character using this move and slide method or function, and every time we press an arrow key on the keyboard, it adjusts a variable called velocity that has 3 values. It's a vector 3 for an X, Y, and Z direction, and it just works. But these if statements only have one result now. If I press the right arrow key, it'll move my character on the x-axis, or more specifically change the velocity on the x-axis and then move using that velocity on that x-axis. But we can actually have more than one result if you press the right arrow key, or more than one thing happen. So I'm going to press at the end of this line under the right arrow key, I'm going to press enter, and I'm going to make the mesh inside this object rotate. So how do you actually target something that isn't this object? You know, if I just said, you know, rotate on some axis, or just rotate and then maybe a number and then close the bracket, that would actually just rotate, you know, the outer kinematic body, which we know is a box. I don't want to do that. I want to rotate something that is a child of this node. What am I talking about here? Well, inside of Steve, if I look at the inside of his scene, Steve is a node, is the root of his own scene. But I want to go from Steve and say, hey, make my mesh instance rotate in certain directions. So how do we do that? How do we say the name of this node? Well, what I can do is go back to my level and go back to the script. Is right here, I'm going to put a $sign. And then I'm going to write the name of the node that I want to target. And if I type a $sign, you're going to see that it lists for me all of the children of this node, of Steve. It has a collision shape, and it has a mesh instance. So I'm going to select the mesh instance, or you can just type it out for yourself. And I'm going to type a dot, because now we can use methods that are built into mesh instances that we're allowed to use. So I'm going to use that rotate one again. So I'll type a dot, just one, rotate underscore Z, I believe. We'll go and check that. If you don't get that prompt, you can just type it for yourself. Sometimes it doesn't quite pick up, and if you type rotate, it doesn't know, it doesn't give you hints. So just type it out for yourself, rotate underscore Z, and put round brackets there. YZ, why aren't we rotating on the X? Well, if I go and look at my 3D scene, if we were to look from the camera's point of view, so this is the camera here, this is the way that we're looking, this red axis is the way that we move left and right, it's the x-axis, but if we're moving that way, we're going to be spinning this way, which is actually on the blue z-axis. So we're going to spin when we move left and right on the z-axis. That's why I'm using, and I'm going to go back to the script now, that's why I'm using rotate Z. If we look at the 3D scene again and we rotate forward and backwards, we're moving on the Z-axis, but we're going to be spinning on the X, on the red, using that hula hoop that I have white right now. Okay, so hopefully that makes sense. I'm going to go back to Steve's code, and we're going to rotate on the Z-axis using not degrees. If I type in 3 here, you would think it would take a number of degrees. No. It uses radians, and you might not be familiar with radians unless perhaps you've passed around grade 10 math or so in some countries. Radians are more tricky, and we're not used to them as much as we are normally degrees from, let's say, middle school or so. So instead of using a number that we're familiar with, we have to use radians. But we can be tricky, and we can convert degrees into radians. So in these round brackets that we're giving to the rotate function, I'm going to put a function called deg to rad, and we're going to put round brackets. It's a method or function call. And in those round brackets, I'm going to type the number of degrees that I want. I'm going to try 8 or so. So what I'm doing here is I'm converting degrees, 8 degrees, into radians, and then it will give the radians to rotate z, okay, on the mesh instance. Let's go ahead and try this out, but I'm going to copy and paste this line, and when we press left, I'm going to rotate the same amount, but negative. And let's do a quick Control S to save, and I'm going to play this scene. This is our level scene. And if I press the right arrow key, I spin, but it's the wrong direction, and yes, left is going the wrong direction as well. So I'm going to change my numbers and flip them, so negative to positive and positive to negative. Okay, let's try that again. And it'll be just a guess and check for you to see what number looks good to you. I think it might be spinning a little bit too fast based on how much it's moving here. So I might try 6 or 7 or 6.5 or 7.2. But what you should do is make a constant. A constant will be used, or it's better to use instead of a hard programmed or hard coded number, because then you can change it just in one place. So I'm going to make a constant. And recall from the last video, I think I actually forgot to mention that a constant is a variable that you don't change during the time that you're running the game. So it doesn't change. The programmer sets it like the speed, and it's always going to be that way when you're playing the game. No one can access it. Yeah, it's just in the background, like a always the same number. So I'm going to name this rot speed. I'm going to make it equal to, I don't know, 7. So now instead of giving the number 8 here, I'm going to give rot speed, and here rot speed, and I think we are good. Let's go ahead and copy this because we're lazy coders here. And when we press up, we're going to be moving on the Z axis, but we're going to rotate on the X axis. So change that, and we're going to leave that the same. I'm going to copy that line again because we're lazy coders. Go down to the down, and we rotate with the, or move towards us with the down arrow key. I'm going to move negative or rotate negative rot speed. So let's go ahead and try this out. I could be backwards there, I'm not sure. If I press right, I'm rotating the right way. Left is good. Forward and back are opposite. So it's a guess and check scenario here. So positive to negative and negative to positive. Let's go ahead and try that out. And we are looking pretty good to me. So I'm happy with that. Now, perhaps it is rotating more quickly than it should if you move diagonally by pressing down 2 of the arrow keys, but I'm not going to be that picky for this first intro game, okay? So that's how you can make things rotate. I'll leave this on the screen for a second, but we've got one more thing to do. We need to look at how to change these actions and change what arrow keys are associated with this action name: UI right, UI left, and up and down. So if you want to be able to play with this game and use the WASD keys, this is how. Up in the project menu, we need to go to our project settings. And recall that the command or method that we're calling is called isActionPressed. So we're looking at action names here. If I go up to project settings, there are lots of categories on the left hand side, but actually we're going to go up to one of the tabs at the top. There's lots of stuff here, so don't get confused. Under input map along the top tab, these are the names of actions that are built into Godot by default. UI select, UI left, UI up, UI down, UI cancel, and they all are actions that have keys or different triggers associated with them. Sometimes they're keys with the little K icon. Sometimes they're directional buttons or joysticks on a game controller. So you can really create these these names for actions and associate whatever keys you want with them, and multiple keys or multiple different types of inputs with them. So I'm going to look at UI left, and it has the left arrow key. This little K icon means key associated with it. What I need to do is, well, you won't have this. You won't have this A here. I'm going to get rid of that. I'm going to press the trash can there to get rid of that. I'm going to press next to left, the plus button, and I'm going to say make a new key mapped to it. So I'm going to select key. It says press a key, so I'm going to press A on my keyboard. It's a capital even though I didn't hold shift on my keyboard. I'll press OK. And now we've got A associated with UI left. I've already gone ahead and done all of these, so I went to UI right. I'll get rid of the D just to show you. I went to this plus next to UI right, and I used a key, and I pressed the D key on my keyboard, and I pressed OK. So now I have A for left, D for right, and if I look at up and down, I've already done these. The W key is up and the S key is down. So if I press close and I go and play my game, I'll just press the play scene button, and if I press the W key, I go forward, the S key, I go back, the A key, and the D key, but I can also use the arrow keys if I want. So now I'm using the arrow keys, now I'm using the A and D keys, okay? That will, I believe, be it for this video. Of course, if you like this video, if you learned something, go ahead and click on that like button below this video on YouTube. And if you want to see more videos like this one in Godot or Blender or technology in general, click on that subscribe button as well, and click on that bell icon to get notified whenever I upload a new tutorial. Check out my Facebook page at facebook.com/borncg. That's where I communicate with people who subscribe and my viewers the most. I post sneak peeks and previews of what I'm working on next. But that will be it for this video. Thanks for watching. Bye-bye.